How can the technology that drives our digital world be more environmentally friendly? Especially with the introduction of artificial intelligence, and we all know about the energy problem that has behind the scenes. So today on Tech Talks Daily, I want to dive into the future of sustainable data center design. And I've got a great guest. Her name is Sara Martin, and she's from a company called HED. And we're going to talk about how data centers are the backbone of our connected lives, but how they are also major energy consumers, responsible for something like 1% of global electricity and responsible for around 1% of global electricity usage. And Sara will share her insights into making these facilities greener and more efficient, and also how they're using innovative techniques like modular systems and liquid cooling. And we'll also explore some best practices for ensuring scalability and flexibility in data center design, which is crucial for accommodating future technology growth, and again, with the heavy usage of AI and how that's going to continue over the next 2 years. And Sara will also discuss strategies for preventing power failures and the emerging trends in data center construction that she's seeing. We're currently producing something like 30 to 35 episodes every single month, reaching around about 130 to 140,000 listeners around the world. So I wanted to mention the sponsor of Tech Talks Daily and also shine a light on how legacy managed file transfer tools are dated and lack the security that today's remote workforce demands. And companies that continue relying on that outdated technology put their sensitive data at risk. But the good news is you can ensure top-tier security with Kiteworks MFT suite. Their software security hardening includes an ongoing bounty program, regular penetration testing to minimize vulnerabilities, the convenience of a one-click appliance update, and avoid the hassle of managing multiple unhardened servers. So why not choose Kiteworks for the highest level in managed file transfer? And remember, Kiteworks is also FedRAMP moderate authorized. So step into the future of secure managed file transfer with Kiteworks by visiting kiteworks.com to get started. That's kiteworks.com to get started today. But enough rambling from me. Let's get today's guest on. So buckle up and hold on tight as I beam your ears all the way to Boston in the US, where we're going to have a fascinating conversation that dives into how we can achieve sustainability without compromising performance. So a massive warm welcome to the show. Can you tell everyone listening a little about who you are and what you do?
Hey everyone, my name's Sara Martin. I work with HED as a sector leader. HED is a national architecture and engineering company, and the sector that I work in is the group that designs data centers for kind of a range of different clients, all the way from hyperscalers to multi-tenant data centers to enterprise data centers. We essentially work with anyone who's interested in getting in the field to your very well expertise and growing their data center portfolio for years, kind of that giant range of clients.
Well, it's a pleasure to have you on the podcast today. It feels like we're in somewhat of conflicting times at the moment. There's a lot of talk around green energy, especially around technology, but equally we're obsessed with AI, and that's got a whole different energy problem. We'll take up an entire podcast episode on its own. But considering the significant energy consumption by data centers globally, which is only going to increase, can you tell me a little bit about some of the innovative strategies that you've employed at HED to design these greener and more energy efficient data centers? Because it's so important, isn't it?
Yeah, it's a very hot topic, no pun intended, with data centers. But one of the things that we really try to do, not only HED, but the industry, is trying to educate people, because fortunately there's a little bit of a misnomer of like, oh, these data centers are using all this power, but lack of understanding of why does that data center exist, and utilization of Netflix, TikTok, scrolling through Instagram, all of those live somewhere, right? And so they live in these massive, essentially, computers that are called data centers. And what we do at the company is we look toward obviously designing across what the client standards are, but how do we try to find more efficient, whether it be new technologies, more efficient layouts that result in smaller building footprints, which then saves you on steel, concrete, et cetera, kind of across the board, create a holistic approach that is looking towards sustainability narrative. I think there is a lot of, unfortunately, misunderstanding around data centers because data centers are designed for power consumption because they're designed to be this massive computer. So there's this idea that they're inherently not efficient, where you could make the argument that they're more efficient than most other building types because no one wants to spend all this money on different systems that aren't the most efficient electrical system or the more efficient mechanical system because at the end of the day that's it all comes down to the dollar value, right? And you want to make sure you're getting the bang for your buck on the systems that are running your servers, et cetera. So for us, as I mentioned, it kind of is a holistic approach, right? It's not only making sure you have paints that are low VOCs and the more kind of somewhat standard approaches with green product selection, but then it's also looking towards new technologies and massive across the industry right now is liquid cooling and how that is bringing the cooling direct to the chip now. Whereas with air cooling previously, you were cooling the space that then go now filters through the rack that filters over the chip, cools the chip, and then is rejected out the back of the server cabinet and then heats up the space again, right? So in that process, there's a lot of room for loss and efficiency as number one, heat isn't as dense and isn't as good of a conduit for the cooling process, whereas liquid going direct to the chip is a more efficient approach. And then there's also a lot of look toward different power solutions and how do we integrate them into the data center industry. So one of the biggest things that's being talked about right now is the utilization of nuclear. And that can range from if there's an existing nuclear plants that are looking to be closed, is that a way that we can utilize existing power without tapping into the grid and potentially causing stability issues with the grid, but also utilizing a more green resource as compared to coal or some of the other options that we've seen historically.
And when we're talking about sustainability and changing that narrative and busting a few myths, there'll be a lot of people listening, a lot of business leaders wanting to make a difference, wanting to make changes, and maybe they're unsure where to start. So what would you say are some of the key considerations for achieving sustainability in data center design without compromising on things like performance and reliability? You've probably seen a lot of things done the wrong way, but what would you say are the key considerations of doing it the right way?
Yeah, so I think when you start looking forward towards AI, a lot of it becomes how do you develop modular systems? There's each component, right? And what is the efficiency or what is the sustainability around that component, right? If it's lithium ion batteries, there's some level of that better than historically the VRLA batteries, but there's also some sustainability issues around lithium ion and how do you dispose of them, some of the fire issues, that type of thing. So there's looking at it holistically of what's the best solution for you for each component, but then simultaneously, how do you build a modular system? One of our clients has taken modular to the next level. And I think through their product, they have a leg up, I would say, in the sense that sustainability isn't just the first day you build the building, right? It's about the longevity of the building and making sure we don't build these data centers that they might be designed around cloud for today and they might turn into AI in the next 3 to 5 years. And do you now need to completely take down that building? Or because you've set it up to be modular, is there this plug and play method that you can swap out your electrical pods essentially so that you can now upgrade from maybe a 2 megawatt block to a 4 or 5, maybe even higher than that megawatt block in the future as the electrical capacity is going to be growing as AI kind of takes off. So I think right now in the industry, it's really making sure you're partnering with the right teams to, one, find the most innovation in the technologies, but also designing around this modularity idea and space saving idea so that you're planning for the future and you're not putting in a technology today that may be obsolete 2 years from now, because we are really at a point where you're seeing a lot of innovation come through, especially around liquid cooling, especially around power efficiency, in order to get ready for this AI demand that's ever growing. Like, I think I've heard that it's supposed to grow 15% power requirements over the next like 7 years up to 2030. So it's we're very much aware of the growth in the industry and where we're going with it. So it's how do you kind of plan towards the future within the restrictions you have today, type of thing.
And it's such an important point you raised there about designing something that's going to be obsolete at 2 years from now with the pace of AI, etc. And two of the other most crucial aspects in data center design is flexibility and scalability. So what best practices do you recommend at HED for planning changes in equipment from facility size or programs to accommodate that future growth? Anything you can share around that?
Yeah, so depending on the client and who we're working with, sometimes they already have kind of their developed kit of parts. But what we usually try to do as a company is to fit with, say, for example, we have a new developer who's interested in getting into the data center industry. What we like to do is sit with them, understand their goals as a company, and then start looking towards building the kit of parts for them. And what that essentially means is, from if you imagine at a very rudiment level, right, you have a block that's your data center. You have your block, so your actual data hall when I say data center. And then you have a block that's your mechanical spaces, that's your cooling to provide to offset the heat that is rejected out of the servers. And then your electrical blocks that are essentially, you'll have some level of configuration to potentially have redundancy. Depending on the client, you could have locational redundancy instead of electrical redundancy, but typically we're still seeing like a 4 to make 3 or 5 to make 6 configuration, which essentially means that if you were to have one electrical block fail, essentially there's an additional one to support it. So what we'll do is we'll sit with the client, understand their goals, and then develop these blocks. And what we've done over time in some of our previous clients, we've been able to utilize those blocks to do exactly what I was just kind of talking about, of the space saving and making sure that you're provisioning for the future. And we've been able to scale up for, I think we started out at a 1200 kW data hall, and then that ramped up all the way to a 3200 kW data hall. So that it was essentially these rows of blocks that we were able to kind of merge together to create that 36 megawatt or 3600 kW. And then over time, we've now grown that to 8 megawatt, 10 megawatt kind of blocks that has been able to scale through the growth of the industry. So like I mentioned, we try to design that around what the goals for the client, right? So if there's specific goals about making sure that they don't have water demand, which is a really hot topic in the industry, of how do data centers impact the utility demand in areas. And a lot of the companies have gotten away from that, but there are still some that are looking towards it because of the efficiency on the electrical side. But so we'll try to work with the client, try to make recommendations there on what makes the most sense from an efficiency standpoint, and then build those blocks around it. Some clients are looking for a little bit more flexibility to be able to swap in and out those systems. So maybe their kind of kit of parts is a little bit more flexible and adaptable, or it has that additional space in it to be able to accommodate multiple different systems, type of thing.
And just to bring to life everything we're talking about here, I don't expect you to mention any names, but are there any specific projects that might spring to mind where HED has successfully implemented some of these best practices we're talking about, and that end result is enhancing data center scalability and flexibility? Any stories you can share there?
Yeah, the one that I just mentioned is the scale from a 1200 kW all the way up to an 8 megawatt, essentially with these kit of parts. So that's been pretty successful. But we've also worked with clients to develop the client that I was referencing previously, the modular systems that are essentially is kind of positions them to be able to have flexibility for swapping out their electrical systems, their mechanical systems pretty quickly in the future. So we've been able to work with them to develop their prototypes and develop multiple prototypes for them that are not only modular but they're kind of scalable for their clients. So they've got a number of different prototypes at this point that they can kind of position within. Say they get a new site, they go, okay, this is what this client's looking for. These are the different types of buildings that we need to place on this campus and be able to reach those goals. So we've been able to work with them to kind of expedite that process as well as the actual design all the way through construction process. And the other thing with modular that we haven't touched on that's very important is when you have the growth in the industry that we have a personnel issue, right? We don't have enough people to keep up with the demand of what this industry is growing to. So that can inherently lead to some issues with efficiency or reliability or even sustainability, because if you don't have the right expertise building these structures or these different electrical and mechanical systems, the repercussions of that can be endless. So having these modular systems that are built off-site and then shipped over to the actual site that the building is being constructed on, it allows for centralized expertise. So you can have these essentially manufacturing plants for these different modular components and have a workforce of highly technical electricians that know how to build these switchboards or know how to build these UPSs and all these different things to be able to kind of simplify the supply chain, but also simplify the manpower issues that we're kind of running into. And you don't necessarily need the expertise on site. It also kind of lends to the ability for us as an industry to continue to scale and build in some of those efficiency narratives.
And I'm glad you mentioned UPSs there. They are often the unsung heroes of IT, and power failures are often a critical concern in data centers. So from your experience, what are the common pitfalls in planning and investing in those uninterruptible power supplies, and how can these outages be avoided? I suspect you've got a few more stories around this too.
Yeah, it's always when you hear of a massive outage, everyone in the data center kind of pauses for a minute, go, did I work on that facility? And you're like, was that me? Was that how was I involved there? But yeah, so we've had a few over the years, nothing too crazy, luckily, but a lot of it comes down to operations realistically, because a lot of the things that we just touched on, the way that the supply chain has kind of been set up at this point is there is a lot of expertise at the manufacturing level. So really what we want to make sure that you're doing is you're designing a concurrently maintainable system. So that means that if there's an issue at the unit itself, then there's redundancy within that you can swap over to one unit, update or repair the issue at the other unit, and then switch back. And that can be at a power level, that can be at a mechanical level. But then also you want to really make sure that at the data center itself, you train for the human error component of it, because while these systems are very efficient and they're very reliable at this point in time through the development of technology, especially for the growth of data centers, you want to make sure that there's preventative maintenance that's going on a regular basis, that your operations staff is very well trained, and that they understand the design itself. You also, from a design perspective, want to make sure that the design is consistent so that when you have an operations staff who's trained on one design, they can go from data hall to data hall and it's the same exact design. They're not dealing with a slight tweak in each data hall. That'll help reduce any kind of power failure issues where your staff is unaware of these nuances type of thing. And then also making sure that they're keeping up with MOPS and the overall making sure the maintenance of units kind of checks and balances. A lot of facilities will do their kind of emergency checks on their generators cyclically. So they'll make sure that they're up and running and reliable, right? They're working the way that they should be working on a regular basis. So you'll be seeing them cycle through that kind of on a yearly basis of each gen gets a day type of thing. And depending on the campus, that can be pretty much every day, depending on the scale of that. But it's really trying to make sure that you have the systems in place to track through all of these things, right? So there's already an efficient system in place. consistent design, and then training your operation staff around that design to be able to avoid the failure at the human level type of thing. And then if you take it a step further, now you're looking at how close the proximity of power is, right? So ideally you want to have that substation on site or very close to the site, so you're not potentially looking at storms taking out, especially with kind of the way things have been going with certain areas where there's the storm surges are kind of getting more crazy. You want to make sure that your proximity to the substation is limiting that potential power failure of taking down power lines and a tree falling and essentially taking down an entire data center campus. So the more you can tie direct to that power source, the better off you are from a campus standpoint perspective.
And I'm curious, we're talking about designing data centers that are both robust against power failures and also optimized for energy efficiency. I'm curious, are there any conflicts or additional challenges that go with that approach?
Yeah, I would say that part of the issue is kind of just how data centers are developed, right? So they are developed to be power consumers. And the biggest issue we're seeing is the power demand in some of the hot markets. So, for example, a lot of Virginia has been for the past couple of years now, and I think projected over the next couple of years as well, they're behind on being able to keep up with the demand in Virginia. So what that kind of results in is now your primary markets are now the demand that was initially allocated towards the primary markets are now hitting your secondary markets. You're starting to see some of the same response there of, is there enough power? Can the utility keep up with the development of substations fast enough to be able to provide the power? And then that kind of is a domino effect, right? One of the benefits of that, though, is that AI has a little bit less of a limitation on location. It's not necessarily a perfect science, but in a lot of cases, they don't have some of the latency issues. So for anyone who's kind of not familiar with the telecom side of things, Ashburn, Virginia is a very popular data center area, and that primarily has to do with the telecom pathways that go through Northern Virginia, and those tie over to Europe and I believe Northern Africa, if I remember correctly. So not only is it a kind of central location for Northern America, where it's close to DC, close to New York, close to Boston, there's also this pathway to connect over to the rest of the world. But with AI, you don't necessarily need that connection and that fast kind of data transfer. So because of that, you're starting to look towards different regions within North America that, or globally really, that aren't necessarily hot data center markets. And in some manners, that's very beneficial for the region because there's usually a lot of growth around it. Like even Ashburn, Virginia has had a substantial amount of development and growth because of the data centers that have been built there. So you're seeing that pop up everywhere else. But it is an ongoing conversation of making sure that the locations that are selected and the growth that's selected for each region isn't also making the grid unstable. So at the end of the day, what it's all coming down to is how do you make the demand fit within the areas that we can build? Because there does need to be a decent amount of infrastructure there. And some of the times you're seeing the hyperscalers of the world. So Meta, Amazon, Google, Microsoft, they're the ones who will move out there first because they have the ability to go to a more remote region, make sure that they can get the telecom there, make sure that they can get the power there, and then everyone else follows. So it's kind of an interesting pattern to watch. You'll see a hyperscaler pop up, and then all of a sudden you start seeing some multi-tenant data centers and smaller data center providers pop up. So it's kind of an ongoing development to try to work through the power demand that's going on across the industry.
And I think tech-fueled innovation will always continuously evolve to meet some of the challenges that we're experiencing today. And if we dare to look a little further ahead, are there any emerging technologies or even design innovations that you see playing a significant role in the future development of data centers? Anything you're seeing here? Anything that excites you at the moment?
Yeah, there's two that one I think everyone's talking about, which is liquid cooling. As I mentioned, it inherently is more efficient, but I think there's some really interesting technologies with submersion specifically. And I think as we're starting to see from like a 6 kW rack to a 300 kW rack, you inherently are going to need to go towards something like submersion cooling. But I think it'll be very interesting to see when that takes off. It's going to be interesting across the board when liquid cooling takes off, because in theory, as you have these high demands, there should be some ability to reduce the square footage that these data centers take up to some level. That's all going to be based off of the AI that is being rolled out within the facility, and what the demand is across the board. But efficiency wise, in theory, a facility that's 8 megawatts today could be I don't know, 36 megawatts facility within 10 plus years from now, and the same exact footprint. It's just a matter of how do we get the electrical systems to fit and scale those. And also, as we look towards this liquid cooling or submersion cooling, what is the reduction there? And then the other one that I'm curious about more from a personal passion standpoint, mass timber has been something that we've been looking at within the company and working with some of our clients on. And essentially, we're looking at data center facilities that are their structures are based out of wood, right? And that's something that for a long time was kind of like, nah, that'll never happen. So it's very interesting to see that start kind of be a conversation in the industry, and it could be a pretty good move from a sustainability perspective. And I'm hoping it kind of takes off to kind of push the needle of, hey, the things that we have kind of said in the past that don't necessarily apply to us, well, we're now making them apply. How do we keep kind of doing that? And we learn from other sectors and where they've been able to be successful in sustainability, and how do we bring them over to the data center industry to keep pushing that needle?
Well, thank you so much for joining me today and sharing your insights. And before I let you go, I'm going to see if there's one other thing you can share with everyone listening. We have an Amazon wish list where I ask my guests to share their favorite book or book that they'd recommend people check out. Is there anything you'd like to add to that list?
Yes, I would love to add Jumpstart Your Career in Data Centers by Carrie Getz. Carrie is a absolutely wonderful woman in the industry that I'm very lucky to know. She has done a lot of work to help build the diversity in the industry, not only for women, but she's a very big advocate for veterans and getting new voices and new ideas into the industry. And as I mentioned, there's a lot we can learn. There's a lot of things we've already done right, but there's a lot of things we can continue to learn. And the more you bring in diverse thoughts, diverse backgrounds, etc., the better off we're going to be. Her book, I wish was around when I started, to be honest, because when I was trying to understand this data center lingo, what a UPS is, had no idea at the start out. And her book helps kind of take away that barrier to entry and really helps dilute the kind of different roles you can take on in the industry, what a data center is, and what are the different parts of the data center that you can potentially get involved with. So very much recommend it. She's a great woman. If you ever end up running into her at a conference, always one worth talking to.
Fantastic. I will get that added straight to our Amazon wish list. And for HED, obviously, we've covered a lot of ground today. Anyone wanting to dig a little bit more deeper on that, how you might be able to help or connect with you or your team, where would you like to point everyone?
Yep. So if you want to reach out to me directly, you can reach out to me through LinkedIn, Sara Martin, and there's plenty of Sara Martins in the world. So definitely look for the one that works at HED, sector leader. And then you can also reach out to us directly through our website at hed.design. There's some contact information in there per office. So you can reach out. I'm in the Boston office. You can reach out to me through that, or just send us a note. And I'm more than willing to always have a phone call and figure out how we can help each other.
Awesome. Well, I'll get all those links added so people can find you nice and easily. And as I said, we covered so much there, from designing data centers to be greener and more efficient, sizing and flexibility best practices, and preventing data center power failures, and even having time to look into the future at some of the trends there as well. So just a big thank you for shining a light on this today. Really appreciate your time, Sarah.
Thank you so much for having me, Neil. It's great.
So there we have it. What are your thoughts on the future of sustainable data centers? Today, Sara Martin from HED has enlightened us with the cutting-edge practices that could revolutionise the way we think about these energy-intensive facilities. From scalable modular designs to the latest in cooling technologies, it's clear that the path to greener data centres is filled with both challenges and opportunities. But the conversation doesn't end here. How do you envision the balance between technological advancement and that hungry AI and environmental responsibility in data centres? Share with me your thoughts. Let's continue this crucial dialogue. Email me, techblogwriter@outlook.com, X, LinkedIn, Instagram, just @NeilC. Let me know. But that's it for today. Time for me to leave you all now, but have no fear. I will be back bright and early tomorrow morning, waiting in your podcast feed. But until next time, stay curious, keep innovating, and I'll speak with you all tomorrow.